National 4-5 waves, units, prefixes, and scientific notation. Within this section, we're going to be looking at SI, that's standard units, prefixes and scientific notation practice, and converting units practice. SI units. Now, there's many ways of describing a quantity. For example, meters, miles, feet, or yards. But in order to avoid confusion, when we're doing calculations, all of our standard equations use consistent or standard units internationally. That means if we're doing a calculation, for example, the speed, distance, time calculation, we always use meters for the distance, seconds for the time, and meters per second for the speed. It's important that we always write down the standard units that we're using, and if we need to, convert to appropriate units where necessary before carrying out calculations. Prefixes and scientific notation are used when we're describing very small or very large numbers to save us writing lots of numbers after or before a decimal point. It's important to be able to use a scientific notation in order to help us convert into standard units before we're doing that calculation. On the next slide, you're going to see a list of very common prefixes and scientific notations. It's really important that you take a note of these and learn them. As you do more calculation problems, you'll get more and more familiar with them, but being able to easily convert between different notations is extremely important because within the National 5 exam, you will find that many of the figures given are given in non-standard units. So here are some common prefixes. Tera times 10 to the 12, for example, terahertz, a million. Giga, for example, gigahertz, times 10 to the 9, 1,000 million. Mega times 10 to the 6, 1 million, for example, megawatts. Kilo times 10 to the 3, that's times 1,000, for example, kilogram. Centi, as in centimeters. And now we see we have changed in the pattern. In centimeters, we're dividing by 100. So instead of having times 10 to the whole number, we have times 10 to a negative number. Also, centi is out of the pattern because all of the other numbers have been multiples of 3. 12, 9, 6, 3. But because centimeters is quite a common unit, we're putting that in this table. We then have milli times 10 to the negative 3 divided by 1,000, for example, millimeter. Micro times 10 to the negative 6 dividing by a million, as in micrometer. Nano times 10 to the negative 9 dividing by 1,000 million. And pico, not very often used, but you should recognize it, times 10 to the negative 12. That's dividing by a million. Let's have a look at some scientific notation in practice. Example 1, we're looking at large numbers. We need to write the distance, 120,000 meters, in scientific notation and express it with an appropriate prefix. Let's look at that number a little bit more closely. 120,000. In order to start putting this into scientific notation, first thing we need to do is to put a decimal point right after the first digit. Then we count how many digits we have after the decimal point. 1, 2, 3, 4, and 5. Now that number 5 is the number of times that first digit has been multiplied by 10. Times 10, 5 times. So now we can express the number as 1.2 times 10 to the 5 meters. Example 2, we'll look at smaller numbers, but we still have a little bit to do in this. We still have to try and put this into some kind of standard notation with a proper prefix. So we have 1.2 times 10 to the 5 meters. Normally, when we're looking at the prefixes, they tend to be in multiples of 3s or thousands. For example, 1 kilometer is 1 times 10 to the 3 meters. So what we need to do is we need to try and change that times 10 to the 5 to something which is a multiple of 3. If a value is expressed in terms of times 10 to the x, we can change that value of x by moving the decimal point on the number forward or backwards. If we're moving 1.2 times 10 to the 5 forward, this becomes 0.12 times 10 to the 6. So you see we've moved the decimal place one place forward, so times 10 to the 5 has moved up one place to times 10 to the 6. Moving backwards, 1.2 times 10 to the 5 now becomes 12, because we've moved the decimal place one step back, times 10 to the 4. So x has been moved back also. So note, if the decimal point is moved forward, x increases. If moved backward, x decreases, where x here is representing the number of times we're multiplying by 10. So now we can express the number 1.2 times 10 to the 5 meters as 0.12 times 10 to the 6 meters, or 0.12 megameters. Or we could express it as 120 times 10 to the 3 meters. That's 120 kilometers. Now let's look at the small numbers. In example 2, we need to write the current 0.00024 amperes in scientific notation and express it with an appropriate prefix. Again, let's look at the number more closely. First thing we need to do is identify the final digit, and then count how many zeros there are before the last digit. 1, 2, 3, 4, 5. So 5 numbers before the final digit, so that means this number has been divided by 10 5 times. The final number is the final whole number within the number you're given. In this case, 24. 4 is the final digit, but 24 is our final number. So we can say that this final number, 24, has been divided by 10 5 times. So the number can now be expressed as 24 times 10 to the negative 5. Note it's times 10 to the negative 5, the negative meaning we're dividing by 10 instead of multiplying by 10. So we now need to convert our number to put it with an appropriate prefix. Our number is 24 times 10 to the negative 5 amperes. We're looking really for multiples of 3, that's thousands. For example, 1 milliampere is 1 times 10 to the negative 3 amperes. As before, if a value is expressed in terms of x, in terms this time negative x, we can change the value of x by moving the decimal point forward or backwards. Remember the rule from last time. If the decimal point is moved forward, the value of x increases. If moved backwards, the value of x decreases. It's the same as whether if x is a negative value or a positive value. So, moving forward, 24 times 10 to the negative 5 becomes 2.4 times 10 to the negative 4. We've moved the decimal place forward, and so the value of x has increased. When you increase the value of a negative number, it becomes less negative. So negative 5 moves up and becomes negative 4. Moving backwards, 24 times 10 to the negative 5 becomes 240 times 10 to the negative 6. We've moved the decimal place back, and so the value of x is now decreased. When we decrease a negative number, it becomes more negative. So negative 5 has become negative 6. We still need to express this within a proper prefix. So we now have 24 times 10 to the negative 5, which can be expressed as 240 times 10 to the negative 6. That's 0.2 micrometers. Or we could express it as 0.24 times 10 to the negative 3, which is 0.24 milliamperes. When we're converting units, it's often useful to use scientific notation because we can simply go from one unit to another by putting its times 10 value. For example, a lot of the time masses are quoted in grams. We can easily convert this into kilograms by saying that grams to kilograms is dividing by 1000 or multiplying by 10 to the negative 3. So grams becomes 4 times 10 to the negative 3 kilograms. So here's some example problems and conversions of units. Have a shot at each one. They get a little bit more difficult as we move across, and the answers are on the next slide. Okay, I'm about to move on to the next slide, which has the answers. If you're not quite there yet, you can pause the presentation here and wait to go on to the next slide. 3, 2, 1, and here are the answers. Now, hopefully, you got all of those correct. If not, a little bit more practice is required, and there will be additional questions for you to practice on included within the work submitted to you on Show My Homework.